So we've been talking about something called functions for a while now, and a function is something in math that has an input and it has an output. So it actually does something to a number to get another number as the output. The word function can be used in a lot of different ways, but as far as we're concerned, it's something that has an input and an output, and we've been filling out function tables to figure out what the value of a function is at different points. So in the opener here, we put in the point, or we put in the value positive 4 as our input and got 9 as our output. And we put 2 as our input and got negative 3 as our output. And 0 as our input, negative 7 as our output. And with all of these inputs and outputs, what we can do is graph the points and get a picture of what it looks like. Sometimes when we have a function, we're going to start with the picture and try to go the other way. So we're going to start with a picture of a function and try to figure out what the values are just based on the picture. All right, so when we have a function like this is a function f of x, sometimes we'll want to be able to look at the picture here. This is what f looks like. Notice that it's a straight line again, back to what we were doing before. So we take the picture of the straight line here, and using the picture, we're going to try to figure out what f of 6 is, and what f of 0 is, and what f of negative 9 is, and what f of 3 is. And we're not going to use a function table to do this, so we don't have the function itself, the equation, but we're just going to look at the picture and try to figure it out. So what we want to keep in mind here is that when we plug a number into the function, this 6 here we call the input, right? Okay, and what is the input variable? What variable are we using for our input? X, and we know that because the function is called f of x, right? So x is the input variable, so I'm going to put that in parentheses here next to input. So 6 is the input, which means that it's the x value. So if I want to know what the value of the function is when x equals 6, I'm going to have to use this picture somehow. Does anybody have any idea how I might do that? So if the input is 6, then I know that what variable equals 6? I know x equals 6, right? So this right here is saying that, I'm going to write this off to the side this way. This means that x equals 6. So in the picture, where does x equal 6? How do I figure out where x equals 6? Emily?
We'll start at the origin and go right near 6.
Good. So, well, we're going to go right 6. So remember, this is the x-axis. Let's go ahead and label that right now. So we're going to go on the x-axis here. I'm going to label the y-axis while we're at it. So I'm going to go to the x-axis and find 6 on the x-axis. So I go 1, 2, 3, 4, 5, 6. And right there is where x equals 6, right here. Now, the function isn't there, is it?
No.
Where is the function when x equals 6, Carl? Up 5. It's up 5, right? So when we go right 6 to 6 on the x-axis, we have to go up 5 to get to the function. Because here's the function right here. So what does that mean? What is f of 6? 5, exactly. So when we went to 6 on the input axis, or the x-axis, we had to go up to 5 to get onto the function, so the value of the function there is 5. Which means that for this function, if we had the equation, if we put 6 into the function, we would have gotten 5 out. All right, I want you to go ahead and try the other 3. See if you can figure out what f of 0 is, figure out what f of negative 9 is, figure out what f of 3 is. All right, let's do f of 0. So f of 0 means that x equals 0, right? So since x equals 0, where are we going to go on the coordinate plane here, on the x-axis? Okay, we're going to stay at the origin. So as far as the x-axis is concerned, we're going to stay at the origin right here. All right, now, to get to the function from the origin, though, which way are we going to have to go? We're going to have to go up how far?
1.
We're going to go up 1. So what's f of 0? 1. All right, how about f of negative 9? So if x is negative 9, what are we going to do, Emily?
We're going to start from the origin, go left to negative 9.
Okay, so this right here is where x equals negative 9. And then from there, what do we do to get to the function?
We go down 5.
We're going to go down 5, which means that f of negative 9 equals negative 5. Perfect. And then f of 3? Well, first we have to go where?
To the right.
We have to go to 3 on the x-axis, so we find 3 on the x-axis, so we're going to go right 3. And then to get to the function from there, we have to go up 3, so f of 3 is?
3.
It's not too bad, is it? That's it. That's the new stuff. All right, now we're going to go through a few more examples. We'll do a function table here to kind of see how the function and the function table relate to each other. But that's it. That's all we're doing. So rather than using a function table to find the values of functions, we're going to use the picture of a function to find the values of functions. All right, now let's go back to the old way real quick. But we're going to do it with a little bit of a different function. This is kind of like the one we saw in the opener because this function has what in it? It has a square in it, right? So let's do the first one together, and then I'll give you a little bit of time to try to fill out this function table. First thing we're going to do is we're going to plug this in. Now I want you to notice you don't have a whole lot of space in your function table, right? It's kind of narrow because we had to squeeze the graph in there also. So make sure that you give yourself enough space. I'm going to write mine up at the top so that I have room underneath to do my work. So I'm going to have f of 6 equals what? What am I going to write in here?
Where'd you get F equals H?
Oh, 12.
Where'd you get
What do I write here? Oh, I'm sorry, not f. Should be what?
H.
Yeah. H of 6. Sorry about that. H of 6 equals what?
12 minus 6 squared over 2.
Okay, so 12 minus 6 squared over 2. Notice that I put the 6 in parentheses. I did that. Really, we'll only need that when the x value, the input, is negative, but I'll go ahead and do it when it's positive also. So in this one, we actually have 3 things we have to simplify. We have the subtraction, we have the square, and we have the division. So out of subtraction, squares, and division, which one are we going to do first? We got to do the square first, right? So this is going to equal 12 minus, what's 6 squared? 6 times 6 is 36, and so we get 36 over 2. And then we have 2 things that we have to do now. We have subtraction and division. Which one are we going to do first between those 2?
Division.
Division comes first, right? So we're going to have 12 minus, what's 36 divided by 2? 18. So we should actually have 2 steps in here because we have 3 things we have to do to simplify it. So the first 2 things that we do, we need to put in our chart here, and then 12 minus 18 is? Negative 6. So we'll write this in function notation now. H of 6 equals negative 6. And then we'll have the ordered pair, 6 comma negative 6. Go ahead and finish up your function table, and while you're working on yours, I'll do mine up here so you can compare what you have to what I have. Now there's a point here that's going to give us a little trouble when we graph it. You guys see which one it's going to be? Which one?
0.
The third one, right?
Yeah.
So 0, 12 is going to be trouble because the graph only goes up to what? It only goes up to 10. So we'll have to kind of guess where that one's going to go. Once you have those done, go ahead and plot the points, but then don't try to draw a line through it. It's not going to be a line. I'll tell you that now. So plot the points, and then we'll look at what it looks like in a second. I put the answers are right here, but I put the wrong things in here and here. I put h of 4 instead of h of 0 on this one. So we'll make this a 0 here. And
You made a mistake?
yep. And then we need to make this one a -2. All right, let's plot these points real quick. 6, -6. What are we going to do? Starting at the origin, we go which way?
To the right.
Right 6 and then down 6. So I think that gets us a point right about there. Then 4, 4 is going to be where?
Right 4.
Right 4 up 4. Get a point right there. 0, 12. We're going to stay at the origin and then go up 12. And since it only goes up to 10, we're going to have to go up an extra 2 there. And so I think it's going to be right about there. And then -2, 10. Go left 2 and up 10. So again, kind of like the opener, what do you notice about these 4 points?
They're not lines.
They're not a straight line, it's a curve. This is again what we call a parabola. Anytime we have an x squared in it, and x squared is the biggest exponent, then it's going to be what's called a parabola, and it's just kind of a U shape. Except this isn't going to be a U shape, it's going to be
A hump shape.
an upside down shape, so kind of a hump or a hill shape. I should also probably label my axes, right? So this is the y-axis going this way and the x-axis going this way. And so if you want to draw the function in here, the function's going to be an upside down U. So it's going to look something like this. Not perfect, but close. And notice that this time at the ends it's going down and to the left and down and to the right. And like we said in the opener, you could put more points in there. You could put in between the 6 and the 4, you could put 5 as an input and see what's going to happen at 5. You could put -1, -3, -4. Put those numbers in there and kind of see what's going to happen at those points.
Are we ever going to have it where, like, instead
What Emily just asked, if instead of x squared we had something like x cubed, or x to the 4th power, or x to the 5th power, you could do that. So if you have something that's x cubed, instead of being just like a U shape or an upside down U, you might have something that takes 2 turns. So this one goes up and then goes down, so it takes a turn. If you have one that's going up and then goes down and then goes back up, that would be maybe like an x cubed, x to the 3rd power. So you can see all kinds of different shapes with your functions when those exponents are different. I do want to point out that example 1, we found the values of functions by looking at a graph and then figuring out what the values of the function are. In example 2, we found the values of functions by actually having the function and plugging in the x values and getting the y values. So there's 2 different ways there that we can find the values of functions. This example is actually one that we've been doing. We've been doing these for quite a while, where we plug values into a function table and then figure out what the outputs are going to be. So let's go back to the graphs and let's talk about how we find the value of a function using the graph. So the value of a function is the blank of the function at a given point. So when we have an input for a function, that's the x value. So we go to the x value, and then how do we figure out what the value of the function is once we're at that x value, at that point? We figure out, we count what?
The numbers. Graphs.
Which way?
Up or down.
We go up or down, right? So the value of the function is really just the height of the function. So the value of a function is the height of a function at a given point. And when we say a given point, this is a given input. So that would be another way of saying it. So for a given input, we go to the x value and then figure out what the height of the function is at that point. So if you have to go up, the height is positive. If you have to go down, the height would actually be negative. All right, now, another thing to keep in mind is that functions don't have to be straight lines. We saw that in the opener. We saw that in example 2. We'll see that here in the examples. You can see on the page example 3 and example 4 have functions that are not straight lines. Most of the functions that we're going to deal with are straight lines, but some of them aren't. All right, and remember, when we get the functions that aren't straight lines, that are not straight lines, that usually comes from an exponent in the function. It doesn't have to. It could come from other things, but usually it's from an exponent. All right, so let's do a couple more examples. In this one here, you guys know how to do this already, so I want you to give it a try. Find the value of the function f, which is pictured there, at 7, 0, negative 8, and negative 3. All right, so for f of 7, where is the 7? Which way do we go to the 7?
Right.
We're going to go right 7 because it's going to be 7 on the x-axis, right? So let's label the x-axis. Let's go ahead and label the y-axis. So if we go to 7 on the x-axis, we're going right 7. And that's going to be right here, I think. And then from there, what do we do to get to the function? We go up how many? 3. So f of 7 equals 3. All right, f of 0. Where is x equals 0? Well, where is x equals 0? It's in the middle. It's at the origin, right? So when x equals 3, we're here at the origin. And then to go to the function from there, we're going to have to go down 3. So f of 0 is negative 3. All right, f of negative 8. Where is x equals negative 8? We go left 8. So on the x-axis, here's negative 8. And then to get to the function, we have to go up 5. So f of negative 8 is 5. Positive 5, right? And then f of negative 3, we go to negative 3 on the x-axis, which is here. And to get to the function, we go down 2. So f of negative 3 is negative 2. It's almost too easy, right? All right, so this last one, we have 2 different functions on the same graph. So you want to make sure you keep them straight. Notice that f of x is the one that curves, and g of x is the straight line. So go ahead and figure out what the values of the functions are. Both of them we're using the same value. So we want to know what f of 8, f of 0, and f of negative 8 are, and then g of 8, g of 0, and g of negative 8. All right, so f of 8. So we're going to go to 8 on the x-axis, right? So remember, these input values are the x values. So on the x-axis, which I'm going to label here, we go to 8. And to go to f, which is in my picture here, it's the red one, right? Yeah. So to go to f, what do we do? Go up 3, right? So f of 8 is 3. Now, while we're at 8, let's go ahead and do g of 8. So for g of 8, we're going to go to 8 on the x-axis, and then we go which way? Up 3. It's actually, since both of those functions go through the same point right here, they actually have the same value at 8. So f of 8 is 3, and g of 8 is also 3. All right, how about 0? So 0, remember, we're going to go to the origin. And starting at the origin, to go to f, which way do we go?
Up 1.
We go up 1. So f of 0 is 1. And let's go ahead and do g of 0 while we're here. To get to g from the origin, we go which way? Down 3. So g of 0 is negative 3. And then f of negative 8, so we're going to go to negative 8 on the x-axis. To get to f from there, which way are we going to go?
Down negative 9. Oh, no.
For f, we're going to go which way? Up 5. So f of negative 8 is 5. And to get to g, we have to go down 9. So g of negative 8 is negative 9. Again, all we're doing here, the only difference between what we were doing before and what we're doing now is that we're starting with the picture of the function, and we figure out what the value of the function using the picture. So you go to the x value and then figure out how much you go up or how much you go down to get to the function itself.